Hello everyone, this is Abdulrahman Salah, former PhD student at the University of Houston, and I will be presenting my PhD research entitled Characterization of the Shear Behavior of Ultra-High Performance Concrete through the Universal Panel Tester. So, UHPC is a new class of cementitious material that has been used in many structural applications. UHPC is characterized by its very high compressive strength, surpassing the normal concrete by more than 5 times, and it has a very enhanced tensile behavior, giving that fibers work in bridging the cracks and increasing the post-cracking strength, allowing more ductile response. Given that the enhanced mechanical properties of UHPC, it's a good material to build durable structures, giving its very low permeability that is less than 10% of that of regular concrete, which could be a better solution in harsh environments, as we know that many bridges in the United States are aged and they need to be repaired. 7.5% of them are structurally deficient. So UHPC can be used in many structural applications, reducing the member size and reducing the self weight of the structure, and also eliminating the reinforcing bars. And it has been used for building facade, and it has been successfully used in long span bridges and bridge overlays. The motivation of this study is derived by the critical gaps in the understanding of shear behavior that is presented in three different tasks. The first one is investigating the axial load effects, which is a key parameter influencing the shear behavior of regular concrete. This phenomenon need to be investigated in UHPC. The second one is the size effect. As we know, in concrete structures, enlarging the structure size does not necessarily increase its shear capacity. That phenomenon is investigated for conventional reinforced concrete, while in HPC it needs to be investigated. Fiber alignment effect is a very important parameter to be investigated for UHPC behavior, given that the tensile strength of UHPC is highly influenced by the fiber orientation. So this was part of my research to investigate the fiber alignment and its impact on the shear strength of UHPC. These three tasks will lead to two important outcomes. The first one is improving the simulation of UHPC response, adopting the softened membrane model, while examining how the fiber alignment can influence the shear behavior of UHPC panels. The other outcome is developing a simplified shear design model based on the lesson learned from the panel tests, along with shear test database from the literature. The machine used in this study is the Universal Panel Tester, which is a multi-axial testing machine at the University of Houston Structural Lab. It has been successfully used for constitutive modeling of RC structures, and it's adopted for testing UHPC panels and investigating their shear behavior. It's the only machine in the United States, and it has 37 in-plane actuators and 17 out-of-plane actuators with 3 rigid links for structural stability. The test mechanism is following the Moore circle, where the biaxial loads are applied in the principal directions, and the element under shear test is rotated at 45 degrees. So as we can see, after loading, the element will experience shear stresses oriented at 45 degrees. And here's a video demonstrating the test. The test matrix consisted of total of 7 panels under pure shear and shear with tension, shear with compression. On the other hand, the size effect study was conducted utilizing total 5 panels with 4 inches thick, all of them except the first panel, which is 8 inches thick. The results showed that additional compression and tensile loads highly influence the shear response of UHPC, as we can see, increasing the compression force by 5% of the compressive strength increased. On the other hand, the depth of the panel also influenced the shear strength of UHPC panels. As we can see here, doubling the thickness decreased the shear strength by 18%, while decreasing the depth increased the shear strength by 10% to 22%. The results from the panel tests under size effect study were utilized to calibrate the size effect factor, and it was found that the characteristic depth of 14.4 was adopted, beyond which the size effect is significant and need to be considered in design. The other part of this study is the fiber alignment, which is a key parameter in UHPC tensile strength, and it depends on the specimen framework size and geometry and casting method and direction. So if fibers aligned in a favorable direction, the tensile strength will be enhanced. Otherwise, there will be variation in the tensile strength response of UHPC. The study was conducted by extracting specimens from the panels and analyzing the images, and based on the area of each fiber through the section cut, the fiber orientation was calculated. The fiber alignment study resulted in a fiber alignment factor that was adopted in the softened membrane model, which is an analytical model that is used to simulate the shear behavior of UHPC panels, which consist of the equilibrium equations and the compatibility equations and the constitutive relations that were modified to suit the UHPC behavior. So the fiber alignment factor was applied to the tensile constitutive law of UHPC, and the results showed enhancement of the shear modeling response of UHPC when the fiber alignment factor is adopted. As we can see, ignoring the fiber alignment factor resulted in 44 overestimation of the peak shear strength. From this lesson learned from UHPC panel tests and the calibrated size effect factor, along with the shear database from the literature, a simplified and practical shear model for UHPC was calibrated and presented. The database consisted of I-shaped and rectangular sections, non-pre-stressed and pre-stressed, and the calibrated equations are summarized here. As we can see, 2 equations were proposed for non-pre-stressed beams and pre-stressed beams, and 3 factors were adopted to account for the fiber alignment phenomena in each, and the shape factor, and finally the calibrated size factor. The performance of the proposed equations is summarized in this table, where we can see no strength ratio fall below 0.75, where the model was optimized to ensure strength ratio below 0.75. With that, I conclude my presentation. Thanks for your attention.